If you remember way back when, we talked about length of an arc in rectangular, and we started off with the length from A to B, and we, I was going to go ahead and derive that here, just remind you how we got that. If we take this arc here in rectangular coordinates here from A to B, okay, so we said, all right, well, if we want to know what the length of the arc is from this point to this point, we're going to build just one line segment. And that one line segment is going to have a change in x, and it's going to have a change in y. And the length of one little line segment was, using the Pythagorean theorem, we have dx squared, the square root of dx squared plus dy squared. So that's how they all started out, okay? And then after factoring out a dx, or rewriting dy, is doing a few things, we ended up getting, for the integral from a to b of 1 plus f prime of x squared dx. So we got that, okay? That's the rectangular one, okay? The parametric one, we ended up doing just recently, and that was the arc length formula would be, again, from a to b, with the square root of x prime of t squared plus y prime of t squared, when x and y dt. When x and y are defined parametrically. So that's the parametric arc length formula. Well, as it turns out, the polar arc length formula is pretty detailed, and I'm not going to go through the proof of it, but I just wanted you to realize that it starts out with the same premise, that you take one line segment, you take dx squared plus dy squared. This comes from the Pythagorean theorem, just like this one did, and just like this one did as well. And you can actually find the length of an arc from theta 1. In this case, we used alpha and beta, so alpha here and beta here. So we can actually calculate the length of the arc from here to here. And in my experience, if you're asked a polar arc length formula, it's probably going to be a circle. Shoot, I'm almost out of storage here. Anyway, what I'd like you to do is I'd like you to pause the video and get yourself into polar mode. Okay. When you get yourself into polar mode, go ahead and go y equals. Okay. So, and when you get to y equals, obviously going to be an r there because you're in polar mode. R is a function of theta. And so I want your R2, I want you to define your R2 to be the derivative of R1, theta equaling theta. So down here you go theta equaling theta. Now theta will be the independent variable button, and then make sure you square it. So that's going to be this part of it right here, dr d theta squared. And then your R3 will actually be this guy right here. Okay, so this is your R3 on your calculator. Okay, actually not that part, but just this part here. And then what we're going to do is we're going to define our R1. Let's just say we take that same function, R equals 1 plus cosine theta. Okay, so R equals 1 plus cosine, and we're going to figure out what's the length of that arc on a certain interval. So pause the video until you get all this stuff plugged into your calculator. And we want to calculate, I want to leave this here, so we're going to put this example down here in this box. Example, calculate the arc length of r equals 1 plus cosine of theta on the interval from 0